we're filming now.
No.
And
If you
just
just,
have conversation, or
yeah, if you just want to start, how you got,
you're recording the speech as well?
Yeah.
You are? Oh, I see. Okay. And you want to just have the speech, a little spiel on how I got into catalysis?
how you, anyone that impacted you to get into catalysis and that sort of thing?
I'm not sure that I was impacted by anyone, but as I was mentioning, I think our early work on the nature of the coordinate covalent bond, the simple reaction A plus B to give AB, was studied a long time, and we ended up with this E and C analysis, which enabled us to correlate enthalpies of interactions, and it's sort of a natural extension of this to worry about, once you form AB, what kind of chemistry can occur on B, which would generate a new product, be a function of how strong it coordinated to A, and then regenerate A in the process. And that, of course, is catalysis. So it's really the next step in complexity of a chemical reaction as an extension of atomic formation. And this kind of thinking got us into homogeneous catalysis. And then we started thinking, well, it might be worth trying to make some real strong acid-solid catalysts, and gotten in the area of heterogeneous catalysis. And now we're really trying to extend some of these studies of coordinate bond strength, the A plus B reaction, where A now would be a catalytic solid. So we would like to treat this as a coordination compound and view the solid like you would a transition metal ion complex, coordinate B to it, and see how different bases bind, and see if in any way this kind of categorization of the solid gives us some insight in terms of its catalytic activity, ways that it might be poisoned, and that sort of thing. So I think this is all pretty much a natural outgrowth of worrying about how molecules bind together.
How did you come to complex chemistry?
Oh, through complex chemistry. Well, this is quite interesting. I was trained as a non-metal chemist, worked with Harry Sisler, and worked on the synthesis of hydrazine. And when I went off to start practicing as a instructor at the University of Illinois, I started research in that area. And I'd also had some students who were very interested in coordination chemistry, transition metal ion complex chemistry, and they got some things started enrolling in that journal area. And then we found out, as we got some results and started publishing papers, that there seemed to be a lot more interest in the transition metal ion chemistry, and not quite so much in the non-metal chemistry. And worrying about tenure and things of that sort, I figured it was a good thing to work in areas where people might be interested. So we started getting more and more into transition metal ion chemistry, and then the NMR of paramagnetic complexes was a big area with us for many years, and the quantitative coordination chemistry of transition metal compounds, and then the use of these kinds of things in catalysis was the next step.
What led you to write the book on inorganic?
Oh, the physical methods. When I came to Illinois, we had a very powerful faculty there. John Baylor, coordination compounds, Lou Audrey, Thurl Moeller, and I could see that if I wanted to teach graduate courses, I was not going to be able to get a crack at doing that in any of the areas that these gentlemen represented. And I started looking around and seeing what kind of background that I really wanted my students to have and know, and try to figure out what was missing. And indeed, it was the spectroscopy area. So I proposed offering a course in spectroscopy, and taught the course for several years. And it was a very popular course, and gave my students the kind of background that they needed to do research. And the book just evolved out of teaching that course. I think just about every book I've ever written sort of has evolved out of teaching a course for several years and figuring I had enough new to offer in the course of teaching the course to make it worthwhile to write a book about it.
And how did the Florida catalysis meeting originate?
Well, this was an extension, really, of the kinds of things that Pierre Levdine has been doing down here for many years with the Sanibel Conference in Quantum Theory. And this has been a very popular meeting of chemists. They bring chemists to Florida to enjoy the warm climate, to do some nice science in the process of enjoying the climate. And it seemed natural for us to try to do something like this in the general area of catalysis. And the first meeting went pretty well. We had about 40 attendees, and it grew to 60, and then up around 80, and leveled off about there. And it's been a nice meeting where we've had a chance to really learn a lot about what people are doing in industry. Our students come to the meeting and learn an awful lot. They have some real good contacts with industrial chemistry, so it's very educational from their standpoint, and gives us a chance to keep abreast of what industry thinks is important in catalysis, which is very hard for us to get otherwise because there aren't any publications that contain this kind of material in it. So it's been fun from that standpoint.
Do you have any feelings why catalysis hasn't been more popular with academic people?
Well, I think it's very complicated. I think academics have not been so much concerned about the practical importance of the research they tackle, but have been more concerned with really the opportunity to get some fundamental information and to be able to solve the problem. And when you tackle something that has as many different kinds of chemistry involved in it as catalysis, it's sort of frightening, I think, and enough to scare people away. But in the past 5 or 10 years, there has been a very big push by NSF for us to not only try to do basic fundamental stuff, but to try and get involved in things that are important as well. And of course, the Pimentel report made a strong push for catalysis, and I think people are now getting the tools which will let them tackle these problems and get some good fundamental answers, and I think there's going to be more academic involvement in it.
Do you have any other?
I think that probably is the gist of it.